Hi everyone, welcome to this video. In this video, we'll be covering AWS NAT Gateway. So we'll be covering what NAT Gateway is, some theoretical part about NAT Gateway such as its limits or the costing part, and then we'll go into a demo. We'll create a NAT Gateway and we'll see how it works. So what is NAT Gateway? So it is a network address translation service, and the purpose of this service is to allow instances in private subnet to connect to services outside your VPC. So if you want to connect from your EC2 instances that are created in private subnet to connect to outside, maybe you want to connect to internet or you want to connect to other services, then you need a NAT gateway. But on the other side, external services cannot initiate a connection with those instances. So it's a one-way route. You can connect from your instances to outside, but the external services cannot connect to your instances. So there are two types of NAT gateway, public and private NAT gateway, and I'll be covering the difference between these in coming slides. So NAT gateways are created in a AZ. So if there is a scenario that you have resources created in multiple AZ that are sharing a common NAT gateway. So in that case, if one of the AZ is down, that means NAT gateway is also down, then the other AZ will not be able to connect to internet or other services. So to avoid this scenario and to improve resiliency, you have to create NAT gateway in each AZ. So as far as AZ is up and running, you are able to talk to other services and connect to internet. So this is some of the theoretical part about NAT gateway. So I won't spend much time here, but I'll just quickly cover. So NAT gateway supports protocols such as TCP, UDP, ICMP, and it supports IPv4 and IPv6 traffic as well. It can process up to 1 million packets per second, but it can automatically scales up to 10 million packets per second. It supports 5 Gbps of bandwidth, and that can automatically scale up to 100 Gbps. So the important thing here is that you cannot associate a security group with an NAT gateway. So in order to do some filtering or traffic filter, you have to define those rules at the instance level, because there you can have security groups attached. So if I talk about the costing part, so when you provision a NAT gateway, you are charged for each hour that your NAT gateway is available, plus each gigabyte of data that it processes. So the costing will be comprises of two parts. One is the NAT gateway cost for each hour, and the data processing cost per gigabyte of data. So the first type of NAT gateway is a public NAT gateway. Suppose you have instances that are created in private subnet and you want them to connect to internet. So this is the requirement. So in this case, how you can do, you have instances running in private subnet. So you need to create a public NAT gateway, and that will be having an elastic IP assigned to it. And you also need to create one internet gateway in a public subnet. So this will be the flow. So in this case also, the outside services will not be able to connect from outside to the instances, but instances can connect to the internet. So you have to associate one elastic IP with the public NAT gateway, attach an internet gateway to the VPC as well. Another type of NAT gateway is private NAT gateway. Again, in this case, the requirement is that you want your instances in private subnet to connect to VPC or on-prem network. Again, it will prevent the outside connection. So in this case, what you have to do, you have to create a private NAT gateway that that will route the traffic through transit gateway or a virtual private gateway. So as compared to public NAT gateway, where we created one internet gateway, here you need to create a transit gateway, because transit gateway will allow connection to other VPCs, and in case you want to do a on-prem connectivity, you have to create virtual private gateway. So this is one of the use case that we'll be seeing here. If you can see, we have two AZs, we have two public subnets created and two private subnets created. And these are some of the instances that you can see. So here we want these instances to connect to the internet. Since these are private subnet, we cannot directly make them talk to internet. So what we will do, we have created one NAT gateway in the public subnet, and we have also created one internet gateway. So the traffic flow will be like that. Private instances will talk to NAT gateway, and NAT gateway will talk to internet gateway, and further internet gateway is connecting or talking to the outside world. Again, I like to reiterate one important thing is that the flow or the traffic flow will be from instances, but if somebody from outside want to connect to your instances, then they will not be able to do so. So let's go to the AWS console, and we'll be creating some of these resources, and we'll be showing how a NAT gateway works. So this is the AWS console. So here some of the resources I have already created. So earlier I have created one video that shows how our internet gateway works. So I have created all the resources till internet gateway, and I'll add the link of that video in the description box so that you can check that video. So I'll just cover what all resources I've already created in order to save some time. So this is a custom VPC that I have created. So I have created two subnets that I'm calling as my private subnet and my public subnet. I have one internet gateway. So this is attached to my custom VPC, if you can see. So I have created these resources as per the network layer, I would say, and I have created couple of EC2 instances, and these instances are created one in each subnet. That is one in public subnet and one in private subnet. So if you see my private instance, it does not have any public IP, and this is my public instance. It is having a public IP as well. So I'll start creating further resources such as NAT gateway, and I'll be creating some routes as well, and I'll show how it all works. So in order to create a NAT gateway, we need to attach one elastic IP because we are creating a public NAT gateway. Say my public NAT. Since we have to create NAT gateway in public subnet, I'll select my public subnet here. So connectivity type, if you see, it's public NAT gateway, and we have to assign one elastic IP to it. So there is one elastic IP that I have right now that is in unused condition. I'll attach this thing. So I'll create a NAT gateway. Okay. So my NAT gateway is now created, and I have two EC2 instances running. Next thing, and the most important thing that I have to do, is to define the routes. So currently this is my custom VPC, and I have only one main route table. So I'll create two route table, for one for each subnet. So this is my public route. So I have this route. I'll add one more route because we have to talk to internet gateway as well. So if any traffic destination is this, then it will go via internet gateway. Okay. And I have to associate my subnet as well. That is my public subnet. I have to associate here. And I'll be creating one more route table that is for my private subnet, my private route. So I'll edit the route. I'll add a route. That means if the destination is this, that is outside, or I would say internet, or anywhere I would say, then the traffic should go via NAT gateway. Okay, so now I have two route table created, and similar way we have to do a subnet association here. I'll associate my private subnet here. Okay, so now I have two instances, so I'll be connecting to my public instance, and then from there I'll be connected to private instance, and then I'll try to access the internet. I'll take the public IP. Okay, so I'm connected to my instance that is hosted in my public subnet. Now I'll be connecting to my private instance from there. Okay, so I'll be doing SSH. Just to show you, I have already copied my keys here. Okay, so if you see, I'm connected to 150.152.150 instance, that is my public instance. And from here, if I just try to do ping google.com, so if you see, I'm able to connect to google.com from my instance, private instance, because now we have set up all the connectivity. And just a use case I'll show you. I'll remove the route to the NAT gateway from my private route table, and we'll see what happens in that case. So this is my private route table and this is my NAT route. I'll remove this thing, and now I'll try to ping it again. See, no response from here. And now I'll add it back. See, it is connected back to it. So I'll reiterate, I'll just go through the design once again. So what we did in the demo is that we had one public subnet created, one private subnet created, and we had internet gateway. So we created a NAT gateway with an elastic IP attached to it. We had two instances, one in each subnet, and the main thing that we did is the route table addition. So we created one route for private subnet and one for public subnet. In the public subnet, we added a route that if the traffic is going outside, then it should go via internet gateway. And in private subnet, we added a route that if traffic is going, and in the private subnet, we added a route if the traffic is going outside, then the destination should be the NAT gateway, and automatically from NAT gateway it went to internet gateway and outside. So this was the whole flow we did in demo. Thanks for watching this video. Please do like, share and subscribe this channel. And if you want me to make video on any particular topic, then please do mention that in the comment section. I'll definitely make a video for that. Thank you.